On behalf of 24HourAnswers.com, I welcome you to today's lesson. In this video, we're going to look at the chain rule, and this video serves as an introduction. This is the long way. We'll talk about all of this, then I'm going to show you a much faster way, and then we'll end the video talking about why you must know the chain rule. Just like product rule and quotient rule, you have to know the chain rule in order to be successful in your Calculus 1 course. So back to this first example here, we want to find the derivative of 2x squared minus 5, all of this stuff cubed. Now, the long way of doing it is to apply some algebra here. So 2x squared minus 5 cubed is 2x squared minus 5 times 2x squared minus 5 times 2x squared minus 5. I've saved a little bit of time here by going ahead and multiplying these two together, as you can see here. Then I brought this one down. Feel free to pause the video and work all this out to check your work. And then we had to multiply this trinomial times this binomial. Doing all of that algebra, we get this thing here. Basically, I've underlined in blue 4x to the fourth times 2x squared is the 8x to the sixth. 4x to the fourth times the negative 5 is negative 20x to the fourth. Then I moved on to this green one with the negative 20, doing the same thing right here, and the same for the 25. Then finally, we combine like terms, and now we have a polynomial that we can find the derivative of. This is the long way. Heaven forbid you had a 2x squared minus 5 to the 10th power. Who in the world would want to do this? Not me. So we got to have a faster way to get this same derivative here. So that's where this one comes into play. How can we do this faster and still get the same derivative? Well, here's what I want to do. I'm going to write this as a composition, and I'm going to show you the two functions that I'm talking about. Composition, f of g of x. All right, let's let f of x be equal to x cubed, and let's let g of x be equal to 2x squared minus 5. It's going to take some practice or some review for you to see the composition of these two functions, but if we apply this composition here, f of g of x, what we're going to do is we're going to take this g here, take this g function, and we plug it into f. So we're going to take this and we plug it into here. Here's what that looks like. Y equals, take that g function, plug it into that spot. We have 2x squared minus 5 cubed. We took this and we plugged it right there into that x. Here is our composition. Chain rule is how you differentiate compositions of functions. And here is the chain rule for the derivative. Y prime is going to be equal to f prime of g of x times g prime of x. Now, that's what you'll probably see in your textbook, but here's how I really think about it. First of all, you have to see that we really have a function, 2x squared minus 5, sitting inside of a function that's getting cubed. I call this function getting cubed, the cube piece, my outermost function. I want to differentiate that first, but when I do that, well, how do we do that? We pull that 3 down just like a power rule. But we leave the inside alone for right now, and I'm going to show you how it matches up with this in a second. So pulling that 3 down, we leave the inside alone. We have to apply the power rule, so this becomes a squared now. We subtract 1 from our exponent, just like basic differentiation. But with the chain rule, once we leave this g of x alone, we come back and we multiply by the derivative of this thing. I call it the derivative of the inside. And the derivative of that 2x squared minus 5, that is our g prime of x. Notice if we found the derivative up here, it would be 4x. This is going to be our derivative. Y prime is equal to the 4x and the 3, we can multiply those to get 12x times 2x squared minus 5. And in all honesty, this is a much better looking derivative than what we had back on the first example we did. This was the same problem, and this is our derivative here. The reason why this one here is a better looking derivative is because it is in factored form. That is going to be very helpful when you go to solve equations where you set the derivative equal to 0 or some other number. But to show you that this is equal to the other piece, let's quickly do some algebra to verify that this derivative is equal to this derivative. And as you can see here, I just took this 2x squared minus 5. I squared those two binomials, distributed the 12x, and simplifying this gives us this right here. As you can see, that matches this derivative perfectly. With that said, I hope you do understand that this way over here, though it doesn't look too bad, had this been 2x squared minus 5 to the 4th or 5th or 6th or even bigger power, this would have been really, really tedious. Whereas over here, we can just apply what we know now as the chain rule. Also, in a future video, what we need to look at are problems like this, where we have the function 3x to the 4th minus 5 sitting inside of a cosine. This is why you must know the chain rule, just one of an infinite number of examples of why. But there's no algebraic approach to this like we did in the previous example. Here we have to apply the chain rule. We'll see this example and a few more in upcoming videos. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.